Okay. I guess we're recording now, so I owe you a couple of things. I owe you your second test marks. I owe you your midterm project submission marks. You need to know about the final submission for the project, and you'll want to know about mentors. Okay. So, test marks. Let's say the weekend, but let's not fool ourselves. It's probably not going to happen this weekend. Maybe it will happen. Project marks I want to give to you on Monday, because you'll need the project, not the marks necessarily, but feedback from if your system is working or not. What happens if you are struggling and you did the project but nothing works? And now, in 2 weeks' time, you have to hand in the final project. In some sense, it's unfair. So, at the very least, you need to know what went wrong in your project the first time around. For the second project, for the last submission, we will have. I put up these these files. So the overview is exactly the same as before. The rules haven't changed. The requirements have changed though. There are new requirements. If I can get to click on it. I have marked some of the new requirements in blue. So there are now 4 modes. You have to add a graphical mode to your project. And you must implement the multiplayer mode. There are a few things that change there, but the most important thing is that there is a whole new section called graphical mode with requirements of how your program must operate in the graphical mode. So it's pretty straightforward stuff. What these requirements basically say is that your program must display the board and must allow the user to make moves on the board graphically, and must display messages in certain cases, like you've won or you've lost. So in essence, I think, shown you this before, in a TUT maybe, but in essence you have to modify your program so that it shows something like this. It doesn't have to look exactly like this. You can use whatever you want. You can use whatever system you want. It has to be Java, but you can use whatever environment you want to write the program. This can look very different in your programs as long as it satisfies the requirements. And part of the requirements is that when you move a piece, the user must be able to click on this board. So either by clicking from the source, I want to move this marker to this spot. Okay, that's not how this program works. In this case, you have to drag the marker to where you want it. So your program must do. I don't care what your program does, as long as it satisfies all those requirements. I wrote down those requirements because that's what I want. And you can do what you want, as long as I get what I want. Hopefully we both get what we both want. Okay. So read through the requirements and ask me in class on Monday if you do not understand or if they are unclear. I'm sure there are tons of mistakes, and if you can spot them, then we can fix them. But. So, these requirements basically describe what I've just told you in more words, but it essentially boils down to the same thing. Now, once again, what happens if your previous submission didn't work at all, and now you've got this big disadvantage when it comes to the final submission? So what we will allow you to do is to, it's not on here yet, but I'll put it up by Monday and also give you feedback on your project so you can decide whether you want to use your own code, the code that you wrote by yourself, nobody helped you, it's absolutely your own code, or whether you want to use our version of the game. But those are your only choices. You can either use absolutely your own code or our code. You can't, this isn't a license to take your friend's code and use that for your final submission. So we'll check that the code you submit is either ours or yours.
So
yes?
Is your code perfect?
No. Is code ever perfect?
Does all the requirements work?
As far as we know. But, I mean, there are extreme cases. So, I'm not gonna promise anything, but at least this code works, satisfies all the requirements majorly. And if you feel that your project does less than ours, then you can choose to either fix yours or use ours. Okay. Right. So on Monday I'll put that up. And then the evaluation. All these requirements are graphical, so we can't write a test. If you're a computer scientist, if you're a programmer, the best situation is if you can automate all your testing so that you know that I have requirements A, B, C, and D, and I can write 4 tests or 40 tests, 10 the test A, 10 the test B, 10 the test C, 10 the test D. And I can run these tests by pressing some kind of button. In Eclipse, there is a button to press that'll run all the tests it can find. You mark your tests and it'll run them. And you'll learn about that in this course or the next course. Well, we've spoken about unit testing, but I didn't show you the Eclipse part. Let's just see if we have time for... No, we don't. It's fine. So in the next course, in 144, you'll learn more about unit testing. But that's the best scenario, when you can press a button and all the requirements are checked. And if one of the tests fails, then you know that that requirement has not been implemented sufficiently. Or perhaps you made some kind of mistake in your test. So I run my 40 tests, I see that some test breaks, I go investigate. Is my program broken? Does it violate some requirement? Or did I just write a poor test and I have to improve the test itself? The requirements we have now can't be tested automatically. We can't write a program to check that your program displays the board correctly. I mean, maybe we could, but that's way too much effort. And nobody does that in real life. When it comes to graphical requirements, things like user interfaces, how do companies do it? How does Microsoft do it? And how does Apple do it? I mean, all these companies have a quality assurance department, and they have 100 or 1,000 or 10,000 people who sit there at a bank of computers and physically do the tests by hand. It's a little more organized than just a lot of hens cackling and doing the tests. There are certain forms and procedures we follow. So you get a form and you have to follow all the procedures on the form and check that you've done each one and then write a little report about what happens in the, with the program. But basically that's all manual testing. All these companies, of course, have enormous banks of automated tests, unit tests that run automatically. But they also have to do this manual testing because you simply cannot test a sophisticated program all automatically. This second handing is almost all manual. So this time your programming style will count 50%, and we'll do a 50% hand marking to check that you satisfy each of those requirements. So what we do is, me and all the other demis, we sit in a big room, we take your programs one by one, and we go through all the requirements. G01, it must display the board. We run the program, does it display the board? No. 0, or yes, you passed that test. Then we take G2, the second requirement. We go through all of them, and that's how we check, that's how we mark your program. It's not straightforward to say that each requirement counts the same number of marks, because some requirements, it's enough to just run the program once and check that it displays a blue dot on the screen. But other requirements are more complicated. Dragging a marker. Do you always drag it correctly, or do you sometimes fail? And what happens if I drag an illegal piece? What happens if I drag it off the board? What happens if I try to drag an empty square? All those kinds of things we have to test. So this is not subjective, but it's not easy to quantify. Right. If your previous project was broken in some way, then you won't lose marks for that again. But on the other hand, just if your program did nothing in the first submission, then you won't get any marks in the second submission. If the faults of your program interfere with our checking of the requirements, so as soon as we start the program in any mode, it just bombs out. We can't check your requirements. We can't give you marks for satisfying those requirements. But if your program had a little glitch, like it didn't display a error message correctly, that won't interfere, I hope, with the graphical mode. So you've already penalized for that. You won't be penalized again. Okay, what else do I need to tell you? 17 May, hand-in date. Last Thursday of the term. Okay. Right. So, evaluation, framework, extra credit. I've made a list of examples of things that will gain you extra credit. So, we don't specify how much you get. Oh, it's still loading. But there is some cap. But you can get extra credit if you implement these things. Some of them, not all of them. But importantly, in the past, we often have students whose programs do not work at all. So you can't play a proper game. The program just terminates immediately when you start it up. But not before playing a little tune. And then that student comes along and says, I want extra credit because I added sound effects. By playing a little tune, that's all my program does. It just plays da-da-da-da-da-dum. Okay, but it's very sad. But you won't get any marks for that, because you should not be spending your time on the extra credit features if your basic program is not working. So do not waste your time implementing the features below if your program is not 100% in compliance with the requirements. So aim for the requirements first. Okie dokie. I have two more things to tell you this morning. The first is that next week and the week after that, these last 2 weeks, we are going to have mentor sessions again. Hopefully during lunch and also at 6 o'clock in the evening. Some people can't do lunch because they have a conflict. Some people can't do late because they need to get back to Pretoria or wherever they're commuting from. But if you can make one of those times, you can attend the mentor sessions. There'll be one every day, but you won't be allowed to attend every single session. So I'd hate for 10 people to sign up for all of the sessions. So we're going to stagger them a little bit so you can't sign up for all of them. I'm meeting the students at 10 to find out when they are available and to sort out the schedule. But once that's done, I'll send an announcement on Sunlearn, and we'll have a sign-up section here. So you can sign. You have to sign up for these sessions. You can't just show up. You have to sign up. There'll only be 10 students per mentor. We cannot afford any more. I don't know if you recall, but 2 weeks ago we had a little mentor session. So I took the 100 students who did poorest in the first assessment. And of those students, 40 showed up. And almost none of those students did any of the quizzes. So almost invariably, when we asked the students, not you, but them, nobody had gone, I don't think anybody had gone beyond quiz 1A. So these quizzes were designed not to teach you to program, but to practice your programming skills. It's the only way you learn to program, by practicing and practicing and practicing and writing programs every single day. So if you haven't done these, what will happen is if you come to a mentor session, we'll ask you to start doing these quizzes. If you struggle with the quizzes, that's fine. You should ask questions. But if you haven't even tried them, I'm a little reluctant to... I'm a little dubious about your commitment to knowledge and your aspirations in life. Yes, Justin?
Can you have quizzes with a project?
I really want to. But these quizzes take a long time to double check, and you know there are still mistakes in some of them. So I'm so far behind. I've got like 5 quizzes in the bank that I can add, but they don't even come close to recursion. Last year I did up to quiz 4E. And this year I managed to add all these questions. But they do take a very long time. Well, if you come back, when you're repeating the course next year, there will be additional quizzes. And who knows how far we'll get.
You can just add like 2 or 1 for each. You add another.
I'll add what I have.
No quizzes.
Thanks. But you must, I want to say, no, I'm not going to add any quizzes. Why must I do all the work in this course? You just sit there all day, asleep, probably. It's excellent practice to make your own quizzes. So if you can find some partner in class, you can make quizzes for each other. It's good practice to make these quizzes, not just to answer them. Okay, one more thing I need to tell you before we can all go home and have a nice little nap. Justin, have you used Standard Draw?
I haven't used Standard Draw.
Not at all.
OMG, dude.
But I've used it so often and it looks so much fun. I drew that map of America.
Oh yeah, side drive.
I know it's not World of Warcraft, but that was great fun doing it ourselves. I was going to show you a program next week, but I'm not sure. I'm beginning to have second thoughts.
Why are the red markers black?
It's an ancient Chinese tradition. No, it's not. It's... What do you want? Red is the new black. No, it's because traditionally checkers markers are red. The black markers are red in checkers. It's odd. I don't know.
What about the black markers?
They are red.
And the red markers?
There are no red markers. There are white markers and black markers. The whites are white usually in a traditional checker set, and the reds are black. Blacks are reds. Oh man.
So we do get a black and red checkerboard.
I didn't hear that, but it sounded hilarious. Okay. Now, I am very hurt. I am hurt and disappointed.
So I wanted to say,
I'm not sorry, but I'm both rueful and lamentful. Yes? That's a quote from Futurama, yes?
the standard rule, the module provided, so didn't really work when I tried to print the folder.
What do you mean it didn't really work?
Because when I used the standard rule given to us in the book, then it only worked.
Look at this great. I mean, it's not. I know it's not Avatar or what's the latest super CGI movie, but this is amazing. This is plasma clouds. It's all recursive. We'll talk about this on Monday. In any case, I love standard draw. I love experimenting with things I can draw myself. So, I thought I'd just show you how to use standard draw to do the mouse clicks. Because much like networking, it's going to kill you. Yes.
If we use your program, you're going to supply a free
My program does not include the code for the new requirements.
No, I get that. But
Excellent, good.
that section on the programming style, then you would only mark it for the graphical model.
The programming style will only be the new code you add. We're not going to remark your old code again, unless it's changed. Okay. Okay, let's get rid of that. That's our Hanoi from the other day. Okay, and let's go new project. Most difficult part of programming is finding the right name. Let's call it. No, let's just call it mouse click. Otherwise, people will just be confused. I'll be confused. Okay? And I want to make a new program called mouse click because I'm going to put it on the web and then people won't know what it's all about. And I also want to use the standard draw that I supplied. It's slightly different from the real standard draw that's supplied by the textbook in that the real standard draw that they have does not include the mouse at all. Also, it's a little funny when it comes to using it together with a textual, non-graphical mode. So you know that there are 4 modes now. Test mode, which must still work, single player, multiplayer, and graphical. And the standard draw that Sedgwick and Wayne distribute with their textbook, if you're not using graphical mode, if you're just using, let's say, test mode, but a part of your program uses standard draw, it'll always open a little standard draw window, which is really odd when you're just working on a console. So this new standard draw is a little bit more sophisticated. Let's write a main. And all I want to do is draw 2 buttons and then read a click and tell which button was pressed. Okay, that's all we are going to do. So I need a copy of the standard draw, which I have conveniently lying around. Okay. Right, now I need to draw 2 buttons. So the important thing about using standard draw is to know what you want to draw. Obviously. But you also have to have some kind of little design in your head about where it should go on the screen. So when you're drawing the checkerboard, you should kind of have an idea of what the coordinates of all the squares will be. I mean, that's easy. We just start at 0. The next one will be 10, 20, 30, whatever. You can work in real numbers, 0.1, 0.2, 0.3, 0.4, what have you. But integers are just so much easier. So I'm going to draw a rectangle. And inside the rectangle, I'm going to draw 2 buttons. So I just want to sketch it out. Okay. That'll be my rectangle. Like so. Okay. And inside here, I need to put my buttons. So well, this is, how do you think UI design works? MS Paint has gained new popularity. You'll be surprised how popular it is. All the cool kids are using it. Okay. Right, and this button I'm going to call A, and this button I'm going to call B. Okay, that's what I want to draw, and I'm going to write down my coordinates. I'm going to say that'll be 0, start of that button will be 10, ends at 20, this one starts at 30, ends at 40, 50. And I'm too lazy to do it now, but the same coordinate system for the up and down. Is it? No. Okay, well, right. So standard draw makes these things really easy. Standard draw dot filled rectangle, and I've got to put the centers, I think. So that'll be 15, 15 for the first rectangle, half width. Well, 5 is half the width. Half height is 5. Good. That's button A. And B is exactly the same, except it's at 35. Okay, small issue though. I'm drawing filled rectangles, but what color are they? And are they, what's the background color? What's their color? So I know you've all read the chapter on standard draw in the textbook, so you probably know this stuff better than I do. But you know that we have to say set the pen color to color dot red for the red pole. Oh, now Eclipse is complaining. It says color cannot be resolved, so we need to do this. Import. We've done that before. And then I'll also need a blue pole. Blue. So A will be red and B will be blue. And background, well, let's draw the background. Let's put it all on a green background. That'll go from 0 to, oh no, midpoint is 25, because this is 0 to 50, so in the middle is 25. And 0 to 30, middle will be 15. Half width is 25 and 15. Everybody happy? What's going to be displayed on the screen? I have no idea, but I guess almost nothing. The whaty? No. I don't have to make the screen where it pops up first. Do I? Well, let's see what happens. Run. Ooh. Didn't like that at all. So I have to say standard raw.init. There we go. Beautiful. 2 buttons. Say again?
That's why we didn't work on because in the other standard draw you didn't have to.
In the other standard draw you don't have to do init. It just always pops up a window. But init is now you have to call it explicitly. Small issue. So we've used this before. You've seen code like this before. Small issues though. This doesn't perfectly illustrate my problem, but where are my boxes? My boxes are, I cannot exactly determine where, but I'm guessing that they are somewhere out over the street. Because by default, standard draw draws 0 to 1. So 15 should be over the grass at the very least. Okay. So I must also tell standard draw what my X scale and my Y scale is. We've done this before. Don't look so shocked. Standard draw dot set X scale. Oh, I can say this X. Min is 0, max is 50. And the Y scale, 0 to 30. And now I'm going to have the next issue. Even though the boxes will appear, they will not be squarish. Why are they so tall? Well, that's 0 to 50, and that's 0 to 30, but standard always opens a square window. So if I want to fix that, I have to set that size. Standard draw.set. Canvas size, width, well, I can choose what I want, but I'll make it 250 and 150. It's tricky to judge because the screen's a little smaller. At home, I would have made it 500 and 300, but I could really make it anything I want. But let's just see what happens here. Maybe it's still too big. Maybe it's too small. Oh, kind of smallish. I could have made it 500 and 300. Okay, fine. As you know, standard draw has commands for writing text on the screen, but I'm not going to do that now to save time. Okie dokie. Now I need to read a mouse click. And this version of standard draw, not the Sedgwick and Wayne, but this version has a routine that says standard draw dot mouse pressed. It's a function we're calling in the standard draw library. It sends back, it went a little fast, but it sends back a Boolean. So an Eclipse pop-up, it says Boolean, is the mouse pressed? Is the mouse being pressed? And it's true or false. So what I'm going to do is I'm going to say while not the mouse is pressed, do nothing. So this is a while loop that does nothing over and over and over and over, while that condition is true. And that condition is true if the mouse is not being pressed. So it's going to carry on pressing the mouse. It'll stop if somebody actually presses the mouse, clicks with the mouse. And then I'm going to say the x coordinate is standard draw dot mouse x and standard draw dot mouse y. These are routines. If you look at the source code for the Sedgwick and Wayne book, for their library, all these routines are actually in there. They just don't work because they haven't connected up the mouse properly, and that's part of the reason why we have to separate out init also from the rest of the code. I wait in a while loop until the mouse is pressed, and as soon as it's pressed, I get the x coordinate and the y coordinate. So this will be some value from 0 to 50 for the x, and from 0 to 30 for the y. And all I'm going to say is if y is more than or equal to 10 and less than or equal to 20, oh dear, somebody collapsed. So if the y coordinate of the mouse press is between if the mouse coordinate of the y press is between 10 and 20, I know it may be in the buttons. But if it's more than 20 or less than 10, I know it's not on the button. So if it's in between 10 and 20, maybe, must. Let's write that. Must. Okay, so it's in between 10 and 20, we know that. It's somewhere in that middle region. It's now off the screen, too lazy to complete the sentence. Right. Oh, this stuff is so easy. I know you can all do it in your sleep. If it's more than 10 and less than 20, then we've pressed button A. Button A pressed. Fine. I'm going to copy that. I'm going to go to the start and say else. If x is more than 30 and less than 40, it's button B, else, and missed again. Copy this lot. Copy, 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 copy. I'm teaching you such bad habits. You guys, me and you, we're all going to hell. We really should not be copying code because copy-paste errors are the #1 source of mistakes in code. Copying large pieces of code, even small pieces of code, is a killer. So you should never be doing that. Don't do what I do. Do what I say. Having said that, it's important to work cleverly and not just type everything out by hand. I'm just getting a headache now. I'm recalling that. I'll tell you now what I recall. Okay, let's test. I'm going to press above 20. So it should say missed. Oh, if I could. Okay, excellent. But why isn't my program stopped? It's still running. What? It's stopping now. No, it's not. What is it executing? It's not the while loop. The while loop is done. It read the x and the y. It checked up on what I tried to. So at the end, we must say standard raw dot. No, not close. Oh man, do I have to read through? Do I have to read through that now to close it? Is it shut down? Does it stop? We have the source code. We can just check. Now this is a long file, and there are things in here which you, innocent people like you, decent Christian people like you, should not be looking at. Hopefully, you'll never ever see this again in your lives. But I can't even find. Okay, fine. Okay, so this is a list of all the routines in standard raw that we can close. Sorry, yes? No. No, it won't be, but let's do it the right way. Keep it. Yeah. I guess we can just clear it. We'll clear work. Okay, right. So, time we learn something new. That's standard raw. So, we can force this program to die by calling a routine that we haven't seen before, called system.exit. And we have to pass it a number. I know you've all seen it because the demos have told you, but officially, you've never seen this before. So system.exit kills the whole program immediately. This is very, very, very bad. We should not be doing this, but at least for now, I'll fix it and put the right solution on the web. Let's just see if it works. Okay, this time I'm going to click in between 10 and 20, but I'm still going to miss the button by clicking in the middle. And it said missed, and it's done. Okay, two more tests. This is how we test your programs. Here's Johnny's program. Does it work if I click on the marker? Button A pressed. Excellent. Does it work if I click on the other marker? Button B pressed. How close to the edge will Johnny's program recognize a click? How close to this edge can I go? Oh. Johnny gets 5 out of 10. I just don't like that shade of green. Okay. So I'll put this on the web. I'll also, I cannot believe I've forgotten it, but I'll also find the right way to quit the program. Do you have any questions you want to ask me about the project? No. Do you have any questions you want to ask me about the mentoring sessions? I'll send an announcement as soon as I've arranged. And I have another class, but then at 10 o'clock I see the potential mentors. And then I'll put an announcement and a booking system. I'll open up the booking system on Sunlearn. Excellent. I'm not going to translate this in Afrikaans today, but I'll mention it on Monday when all the other students also come to class. And maybe I'll sell this YouTube video to them. Maybe.